put rocks of different shades under the solar death ray to see how they responded. A black, gray, and white rock. First to go on the hot seat was the black rock, and I expected this to react violently to the concentrated sunlight because of its dark color and ability to absorb light. It did not disappoint. As soon as the concentrated sunlight hit it, it started to fragment and throw pieces of rock all over the place. This was totally awesome to watch in slow motion. There were cracking and popping sounds as the high-intensity light dug into the rock. Very quickly, the rock fragmented and broke into all sorts of pieces. Black rocks are some of the best reacting objects under the solar death ray, and I loved this one. When I took the light off, I just had to scrape the pieces off the hot seat and get ready for the next rock to go there. The gray rock was the next one to go under the solar death ray, and it did not disappoint either. It did fragment initially somewhat, but then it quickly began to melt, and a closer look showed that a pool of lava had formed on the surface. In contrast to the black rock, the gray rock quickly melted and formed lava, then obsidian. The last one to go under the giant lens was a very light-colored rock, and I aimed the harnessed sunlight right at its surface. This white rock was much brighter to look at because it was reflecting much of the light, but it still succumbed to the powers of the solar death ray. I left the white rock under the lens for a long time and it did not crack at all. And when I disengaged the solar death ray, I could see that the surface was melted. Here's the resulting mayhem. There were fragments of black rock all over my driveway, and the gray and white rocks had melted surfaces.